sun, and I line the foci of an ellipse, which we learned about in the conic sections unit of pre-calc. Now, what's the significance of this ellipse, you ask? Well, it's the path that Mars takes around it. Now, you're probably wondering what an ellipse actually is. Well, the standard form of an ellipse is x squared over a squared plus y squared over b squared equals 1, where a is the horizontal distance from the center to the rightmost point, and b is the vertical distance from the center to the topmost point.
Whoa, that's an ellipse.
The importance of the foci is that the sum of the distance from the two foci to any point on the ellipse is always constant.
Here's the path of a planet around the sun, and you would notice it takes the form of an ellipse. But there are some pretty significant points. Right here is the perihelion. That's the point where it's closest to the focus, or in this case the sun. This is where the planet actually moves the fastest in its orbit. And over here is the aphelion. That's the furthest point from this focus, also known as the sun. And that's where it moves the slowest.
Oh my god!
Gravity pulls objects towards the sun, but the objects are also moving forward very fast. And this creates a balanced elliptical orbit.
It's important to understand ellipses in this context because it helps us do many things. It helps us model planetary motion, design spacecraft, and more.
There are many examples of space missions where the understanding of elliptical motion is necessary, like the Hubble Space Telescope, the Apollo missions, Mars missions, and even GPS satellites.